Good day, ladies and gentlemen. Welcome to Code Switching 2020. Today we continue with physical sciences, looking at electric circuit. This will be our question number 5. So before we start answering the question, please pause the video, try it out, and come back and check if your solutions are correct. Without any waste of time, today's question is as follows. Number 1, they said in the circuit diagram, the battery has 36 volt and no internal resistance. Then the questions are, what is the reading on voltmeter when both switch S1 and S2 are open? Number B, determine the total resistance of the circuit when both switches S1 and S2 are closed. Number C, what is the ammeter 1 and 2 reading when both switches are closed? Then number D, how will the energy produced by the battery change when one of the switch is open? Explain. Okay, let's look at the circuit. In our circuit, we're given our battery. They said our battery has a voltage of 36. Then we have ammeter reading 1, and we have also the second ammeter. So we also have the resistor of 12 ohm, 15 ohm, and 6 ohm. The voltmeter, which is connected in parallel to 12 ohm and 15 ohm. So let's answer the first question. The first question said, what is the reading on the voltmeter when both switches S1 and S2 are open? So meaning, if the amp of the battery is 36 volt and there is no internal resistance, it means solution for number 1, the reading on this voltmeter, this other part will not function because of both switch 1 and switch 2 are open, so there's no current flow in this side. So meaning the reading on the amp will be the same as the reading on this voltmeter. Because of the circuit will be, the current will be flowing from the battery to ammeter 1 to the voltmeter reading and to only 6 ohm resistor. So meaning the voltmeter will be 36 volt. I hope it made sense. Number B, determine the total resistance of the circuit when both switches S1 and S2 are closed. When S1 and S2 are closed, it means now we have the parallel resistors. 12 ohm and 15 ohm are in parallel. So for us to calculate total resistance, we must start by calculating the total resistance in parallel. So we'll say 1 over Rp will be given by 1 over R1 plus 1 over R2 plus, depending on how many resistors we are given. Since we are given only 2, we're going to use R1 and R2. Then correct substitution. This will be 1 over, let's say R1 is 12 ohm. This will be 12 plus 1 over 15. So for us to get Rp, we'll say Rp will be equal to, you open brackets, 1 over 12 plus 1 over 15, close brackets, all to the exponent of -1. This is what you punch on your calculator. Then our answer for R parallel will be 6,67 ohm. Then the parallel the total resistor in parallel will be in series with 6 ohm. Therefore, R total will be given by 6,67 plus 6 ohm, which equal to 12,67 ohm. This is the total resistor of the circuit. So let's look at number C. What is the ammeter 1 and 2 reading when both switches are closed? Number C, ammeter 1 is the total current that flows in the circuit, but when ammeter 1 gets at this point, gets divided into not at this point, get divided into 2. Other goes this one, another one goes this way. So let's start by calculating the current through the ammeter 1, which is the total current. We'll say total current is given by the total voltage over the total resistance. Total voltage was given, that is 36 volt over total resistance, which we got to be 12,67. And when you punch on our calculator, our total resistance is 2,84 amperes. So 2,84 amperes, when it gets at this point, gets divided into the ratio of 12:15 of the resistance. Then when you simplify, this ratio is the same as 4:5. So when we need to calculate our current through ammeter 2, is the same as the total ratio, which is 9, and because of it goes to 15, this will be 5/9 multiplied by the total current, which is 2,84. 2,84, meaning 5/9 multiplied by 2,84 will get 1,56 amperes. This is the current that will flow through ammeter reading 2. Let's look at question number D. Number D, the question says, how would the energy produced by the battery change when one of the switch is open? Explain. So let's say switch 1 is open, remains open, and switch 2 is closed. So when switch 2 closes, the total resistance of the circuit becomes 12 plus 6. 12 plus 6, we get 18 ohms. But remember, the total resistance before, it was 12,67. So meaning, number 1, when switch number 1 is open, if S1 is opened, the total resistance of the circuit will increase. And when resistance increase, what happened to current? Remember, resistance is inversely proportional to the current, meaning when resistor increase, current decrease. So, and the current will decrease. So the energy, which is the power is given by I squared R. So meaning when the current decreases, because of, I'm supposed to set power, I wrote R here, it's P. Energy is given by the power is I squared R. When current decreases, and power is directly proportional to the current and also the resistance. So when one of the two decreases, it means the energy also decreases. So we say, therefore, the power of the battery decreases. That will be all for today. For more videos, please go to Code Switching 2020. Thank you.